Hi guys, happy Monday. Today we're gonna be learning about identifying linear function from nonlinear and identifying arithmetic sequence. So please make sure you do everything on the agenda and let's go ahead and get started. All right, so a linear function makes a straight line. It has a constant rate of change. The equation of a linear function will not have any exponents greater than 1. Its equation is in linear function form. And what that looks like is like, for example, y is equal to mx plus b, where the b represents the y-intercept and the m is the slope. All right, so then we have whenever a function is nonlinear. So that's going to be the graph of a nonlinear function is not a line. Nonlinear functions have a slope that changes between points. So it's not constant, all right? In other words, is the complete opposite of a linear function. So it says identify the equations as linear or nonlinear. So let's see, let's look back at our notes. If it's linear, we said that it's gonna be a straight line, it's gonna have a constant rate of change. What is another word for rate of change? Well, that is slope, right? So, and the slope is gonna be this part right here. So it has a constant rate of change, and the exponent is not greater than 1. The exponent here is 1, right? There's nothing there, that means it's a 1. So this one would be linear. What about this one? We have the slope. The exponent is 1 because there's an invisible 1 right there, but we just don't write it. So this one would also be linear. And right here, what this means, I'm gonna go ahead and rewrite this. So this is f of x is equal to 2x squared minus 5, okay? I just couldn't figure out how to make the squared, but yes, that's what it looks like. So we have our slope, and we can see that the exponent is clearly greater than 1, right? So it's 2, so that would be nonlinear. And for this one, I'm going to go ahead and rewrite it. F of x is equal to 3 to the x power plus 9. Now, whenever we have to the x power, well, we don't know what that is, right? So that's going to be nonlinear because it can be greater than 1, the exponent. All right, so those are some ways to figure out if it's going to be linear or nonlinear. Of course, if you were to graph these, you would clearly see that it's not a line. But yes, I'll let you guys practice that. Now we're going to see how it looks like whenever it's on a graph. So we said linear clearly is going to be a straight line, right? This one is going to be linear. This one right here, right next to it, is not going to be linear because it's not a straight line, so non-linear. And then we have the bottom one, also a straight line, but is the opposite, right? So, but that doesn't matter, it's still linear. And the one next to it, well, it has all those curves, that means it's non-linear. The one on the bottom left, well, that's a parabola, and that is non-linear because it's not a line. And this one is linear because it's a line. So pretty self-explanatory. It's really easy to visualize it, or to understand once you have the visuals. So basically, if it's not a straight line, it's not linear, okay? All right. Identify the tables are linear or non-linear. All right, for this, we're going to have to write down the the formula for the change of y over the change of x. And this is the same thing as the slope, or m, okay? So the way that we're going to do that, well, we're going to see the difference between every x value and every y value. So what's the difference between these two right here? Well, the way that we're going to find the difference is we're going to do 0 minus negative 1. 0 minus negative 1, well, that's just positive 1. 1 minus 0, 1 minus 0 is just 1. 2 minus 1, well, that's just 1. Now, what's 3 minus negative 1? Well, that's going to be 4. 7 minus 3, that's 4. And 11 minus 7, well, that's 4. Now, this is the same thing. Remember, f of x is the same thing as y. So now we look back at this formula right here. What is the change of y over the change of x? Well, that is the 4 over the change of x. Well, it was 1. So 4 over 1, that's the same thing as just 4. And we can see that all of these were constant. Remember, linear functions are constant. These were all constant, and these were all constant. And we were able to get our slope. The slope was constant. So this means that this is going to be a linear function. All right. Now let's go ahead and look at the next one. Well, what is the difference between 4 and 1? That's going to be 3. 5 and 4, that's 1. 5 minus 4 is 1. 7 minus 5, well, that's 2. And over here, 2 minus 1 is 1. 3 minus 2 is 1. And 4 minus 3, well, that's 1. But we can see right here that this is not constant. You know how over there we had the 4 and then the ones that they were all constant, the difference was the same, and here it's not consistent. So this means that it's going to be nonlinear. Okay. All right, for the next one, let's find the difference again. So what is 0 minus negative 1? Well, that's just going to be positive 1. 1 minus 0, 1. 2 minus 1, 1. Now, what is 3 minus 3 over 4? I'm going to go ahead and do it right here because I don't know. 3 over 3 minus 3 over 4, and then multiply by 4. So that's 12 minus 3 over 4. That's going to be 9 over 4. Okay, so we have 9 over 4 is the difference. And then what's the difference between 12 minus 3? Well, that's going to be 9. And then what's the difference between 48 minus 12? Well, that's going to be 36. And I probably should have done that in a different color. Sorry, guys. I'm going to just go ahead and put a circle around them so that you can see the difference. So these are all the differences. As you can tell, these are not consistent. Remember, for a function to be linear, they have to have a constant slope. And we can see here that it's not the case. So this is also nonlinear. Oh, sorry. All right. So now we have an arithmetic sequence. We're going to be learning about how to identify arithmetic sequences from geometric sequences. So an arithmetic sequence goes from one term to the next by always adding or subtracting. So by adding or subtracting the same value. This value is known as the common difference. A geometric sequence goes from one term to the next by always multiplying or dividing by the same value. This value is known as the common ratio. Oh. Okay. All right. Let's go ahead and see some examples. So we have classify each sequence and find the next term. So let's go ahead and take these two and see if we can find a pattern. So how did they go from 1 to 3? Well, they probably added 2, right? How did they get from 3 to 6? Well, they probably added 3. And then how did they get from 6 to 10? They probably added 4 because 6 plus 4 is 10. How did they get from 10 to 5? Well, they added by 5. So as we can see here, we found a pattern, but by the definition, it says that an arithmetic sequence goes from one term to the next by always adding or subtracting the same value. Even though we found the pattern, this is not the same value. It's 2, 3, 4, 5 is not the same value, right? So this would be neither, or actually not none, but neither. All right. And since we do know a pattern, probably the next one is going to add by 6. So what is 15 plus 6? Well, that'd just be 21. Now, for the next one, how did they go from 4 to 16? Well, they probably multiply by 4, but let's see if this pattern continues for the rest of them. Because remember, they have to be the same value. So what is 16 times 4? Well, that is 64. So what happened to the 36? They skipped it, right? So that means that it's not a geometric sequence. Now, let's see if we can subtract them and find a common value. So what's 16 minus 4? Well, that would just be 12. And then what's 36 minus 16? Would that be 20? And then 64 minus 36? Well, that would be 28. So again, we don't have a pattern here. So this would also be neither. All right. So, and we actually wouldn't be able to really figure out what's the next term because we couldn't find a pattern, right? All right, for the next one, -4 and 12. So let's see, let's try to multiply something. So maybe if I multiply by a -3 here, because a negative times a negative would give me a positive, so that would give me positive 12, sorry. And then let's see if I multiply this 12 by -3, if it will give me -36. It does. Now, if it's -36 times -3, let me see, 36 times 3. Yes, it does give me 108. So we see that we found the pattern, and this was all by multiplying, okay? All by multiplying. So would this be arithmetic or a geometric sequence? Well, this would be geometric, because geometric is whenever you have a common ratio because you're multiplying or dividing. All right, for the next one, let's see if we can find a pattern between the 0 and 3. So 0 plus 3 will give me 3, right? 3 plus 3 will give me 6. 6 plus 3 gives me 9. 9 plus 3 gives me 12. So that one was easy. We found that if you add 3 to each value, it gives you the next value. So this would be arithmetic. Arithmetic. Now for the next one. We have all of these values, and we also have some decimals. So let's see if we can find something. So if we subtract 18 minus 9, we get 9. And 9 minus 4.5, we get 4.5. So this would be 9, this would be 4.5, and this would be 2.25. So as you can see, there is no sequence, there is no common value there. So let's go ahead and see if we can maybe divide. So 18 divided by 9, well, that will give me 2. Now I have to see if I divide 9 by 2, if it'll give me 4.5. So if you put on your calculator 9 divided by 2, it does give me 4.5. So that's good. Now 4.5 divided by 2, it gives me 2.25. So that's good. And this we divided, right? So this would be also a geometric sequence. All right, guys, hope that was helpful. If you still have any questions, please feel free to ask your teachers. Don't be afraid to ask for help, okay? Y'all have a great day.